There was just a major earthquake off Russia yesterday.
Mhm.
I wanted to get an idea from you what causes an earthquake.
So it's a truly large earthquake. Magnitude 8.7 is the largest of the large, the sixth largest in the last century. So nothing to sneer at. These really large events are what are called subduction zone earthquakes, which sounds really technical, but what it means is it's an earthquake where two tectonic plates crash into each other. And so at these places, the tectonic plates are usually stuck. They're not moving over the years and decades, but eventually they become unstuck. They let go. And that letting go of the tectonic plates is the earthquake. And so here in this part of Russia, in Kamchatka, these are fairly common. They had a magnitude 9 there only 75 or so years ago in 1952. So it's large, but for this part of the world, it's fairly common geologically speaking.
And how are they measured?
So they're measured using this magnitude scale that we call that the moment magnitude scale. Your viewers or listeners might be aware of the Richter scale. We don't use that anymore. Right now, we use something called the moment magnitude scale, and basically that scale depends on the length of the earthquake. This one was about 300 miles long, which is pretty impressive, and how much it moves. In this case, it moved about 30 feet. So depending on that length and that amount of motion, we have a formula that says then you get magnitude X. In this case, magnitude 8.8.
We know that often an earthquake is followed by a tsunami. Why is
Yeah.
that? How is that?
Yeah. So first of all, the earthquake needs to be offshore, so where there is water to move. So earthquakes that are on land, like on the San Andreas Fault in California, they will not produce a tsunami. There's no water to move. But these big events offshore, the fault moves, as I said, about 30 feet in this particular one. And so as the fault slides, it shoves the ocean water above it. It shoves that ocean water up and down. And that sets up the wave that then propagates away from the earthquake region.
Is there a certain magnitude of an earthquake that there needs to be offshore before there can be a tsunami? Or does it matter?
All earthquakes offshore produce a tsunami. It's just that some of those tsunamis are so small that nobody ever notices. So a magnitude 6 earthquake offshore will produce a tsunami that's tenths of an inch, teeny tiny. And so, no, any earthquake offshore will move the ocean and will create a wave. For humans, we typically don't begin to see significant impacts until we get to about magnitude 8, roughly. Once you get close to magnitude 9, it can be really, really bad, right? In 2011, in Japan, magnitude 9.1, 20,000 casualties. In 2004, in Indonesia, magnitude 9.2, 200,000 casualties. So, right around this magnitude that we're at right now with the Russia earthquake, 8.8, that's when we are really, really concerned for tsunami impacts.
Leaning into that,
Mhm.
there was a 9.0 quake, magnitude 9 quake some decades ago,
Mhm.
off, and it caused 30-foot waves in Hawaii.
Mhm.
This was 8.8.
Yeah.
What stopped it from doing the same thing?
Yeah. Well, we're figuring that out. It's only been a day, and so we're still picking apart the details of the earthquake. But 8.8 compared to magnitude 9 might sound not that much. It's not that much smaller. But you have to remember there's like this odd quirk of how we calculate magnitudes that it's what we call a logarithmic scale. And so between magnitude 8 and magnitude 9, an earthquake is 30 times larger. And so between magnitude 8.8 and magnitude 9, an earthquake is 2 times larger. So even though it's only 0.2 magnitude units, the physical size is about 2 to 3 times as large. So this earthquake was significantly smaller than that one in 1952. So that's part of the story. The other part of the story is that each earthquake has its own personality. Some earthquakes move more, some earthquakes move less, some earthquakes move certain parts of the fault, some earthquakes move other parts of the fault. And so, as we uncover those details, we'll be able to answer more precisely why this one produced a tsunami that was a little bit smaller than the one in 1952.
And you said that this one was about 300 miles wide at
Yeah,
8.8 magnitude.
yeah.
Roughly, could you estimate how wide a 9 magnitude, how wide it would be?
Well, we've seen that. We know that. I mean, I can give you an example. They can be really big. The 2004 Indonesia earthquake, that one that killed 200,000 people in many different countries, that one was 1,000 miles long. Yeah, yeah. And that one was one of the longest ones. They don't always have to be that long, but it can be that long. And the 1964 Alaska earthquake was about 700 miles long. The 1960 Chile earthquake, also a magnitude 9, was about that same length. So these events can be really big, right? The human mind almost struggles to understand how that amount of the earth can all rupture, can all break in a few moments.
That definitely put it in perspective to go from an 8.8 at 300 miles wide to
Yeah,
double, triple that
yeah. Yeah,
width.
that's why these tsunamis can be so scary, because imagine that they not only make big waves, but because so much of the earth has moved, those big waves can span thousands of miles of coastline. So what I tell folks is, think of Hurricane Katrina, that produced storm surge in the New Orleans region. Imagine if we had Hurricane Katrina level flooding across 1,000 miles of coastline. That's what we're facing with these really big tsunamis, and that's what makes them so scary and why we need warning systems.
And how do we know when that period of the tsunami danger has passed? What is the aftermath of that?
Yeah, that's a wonderful question. It depends a lot on the size of the tsunami. If there were big waves, we're typically talking about a day or more where there can be significant effects. And also, if there was any inundation on shore, it's going to take time for the inundation to draw back out into the ocean. And in some places, for the biggest earthquakes, hazardous currents can remain sometimes for 2 days or more. As the waves kick around, we might no longer be able to see them, but the currents can remain dangerous, especially for ships. And so for harbors that we rely on for all our shipping, these can be a major concern.